All right, good morning, folks. We're going to get started in just about a minute or so. I'm going to wait a couple minutes just to make sure that folks get into the Zoom room okay. Hope everyone's having a good start to their summer so far. All right, so folks, we're going to go ahead and get started here. So good morning. Welcome to Math 151. My name is Judy, and I'm going to be your instructor for the summer. So we have an 8-week course. So you've all chosen to take a full semester course and condensed it into an 8-week course. It'll definitely be a lot of work, but hopefully we'll have some fun along the way as well. So I thought we'd get started this morning. I wanted to show you the Canvas shell, just do a quick walkthrough of the Canvas shell just so we know where all things are. And I'm gonna go ahead and share my screen right now to do that. All right. So hopefully most if not all of you should have access to Canvas. When you sign into Canvas, the way I've designed the shell, and I know all professors design it differently, is that your home page has pretty much everything you need, okay? So on your home page, you'll see the logistics button, which I think you've all found already because you found the Zoom room. But I've linked the syllabus here, the summer schedule, the Zoom room link, as well as the password, and a little blurb on how to take and submit quizzes and exams. Okay, so make sure that you take a look at this in more detail, but let's take a look at it quickly because we actually have a quiz due tomorrow. So for quizzes, you're going to go to the quiz assignment. If you have access to a printer or a tablet, and I know not everyone does, but if you do, please print the quizzes or the tests, or import the quizzes or tests into your tablet. But if you don't have that kind of technology, you can certainly do your work on a separate sheet of paper, and that is totally fine. But when you submit the quiz, make sure that you take pictures of your work in order, okay? And then save your quiz as your first name, last name, and then quiz number. You can upload that right to Canvas, and I'll show you where you can find that in just a little bit, okay? Make sure that you take a look at the directions for the exams. We'll go over that next week before our first exam, but take some time on your own to read that over. If you have any questions on technology, definitely let me know or reach out to some of your peers in this class. I'm sure that people have their own ways of doing things, and I just want to make sure that it's a smooth experience for all of us, okay? So let's go back to the homepage for a moment. So that's the logistics tab. It has like sort of the nuts and bolts of what you'll need to navigate through the course. As far as course content, you're going to find it under any one of these tabs, okay? So we're going to be starting with chapter 9. So if you click on chapter 9, it should have a drop-down menu. And it has all 6 sections that we're going to be doing in chapter 9. In each section, so for today, we're going to do 9.1. If you click on 9.1, then you'll find a few links, okay? The blank notes are there for you. Again, if you have a printer or you have a tablet, you're welcome to download that or print it out so that you can write right on that. After class, I'm gonna upload my own complete notes so that you'll, in case you missed anything or you know, you weren't able to make lecture, you can go ahead and find the complete notes. And then the link to our video will also be here in case you're ever unable to make lecture, okay? This is going to be the same setup for every section that we do. So every section will have blank notes, we'll have complete notes, and a video link. I did want to highlight one section. So there's this integration review. If you've recently taken Calc 1, this might be a little fresher for you. If you have taken Calc 1 kind of a long time ago, you might want to take some time to go through. I've summarized some of the things that I think are really important and might help you be really successful in this first chapter, but also for the whole course. So you can go and find lecture videos for different questions, a lot of practice problems, especially around things like U substitution that sometimes we don't always catch on to right away, but we're going to start today with a whole bunch of other kinds of integration techniques. So I just want you to have something to fall back on in case you feel like it's just moving a little bit fast in the beginning, okay? All right, so we've got all of our content pages, okay? I think I've gotten through chapter 12, but I don't have everything up. So if you click on like chapter 6 and there's nothing there, that's okay. I just haven't gotten there yet, but things will be up in advance. I'm going to be sending out announcements from time to time. So please make sure that you read through the announcements. I know sometimes when you check them like in your email, it doesn't include all the links. So it might be worth just coming into Canvas to make sure that you're able to check the announcements, okay? As far as assignments go, this is where you're going to find all of your assignments. So for our class, we're going to have some quizzes and we're going to have some exams. And so all the quizzes are here already. I think I finished through quiz 7. So again, if you look really far in advance, you might not find the quiz you're looking for, but if you want to work ahead at this point, you're absolutely welcome to do so, okay? So for example, let's take a look at quiz 1, which is going to be due tomorrow, June 16th by midnight. So if I click on quiz 1, and I open up that document, it should link you right to my Google Doc that has quiz number 1. Okay, now quiz number 1 is like all the quizzes are structured so that they cover the content of the 2 days before. So for example, tomorrow's quiz will cover the content we do today as well as the content that we do tomorrow. It might not be a bad idea to kind of make that your like regular check-in after lecture if you can spare a few hours afterwards to just crank out all the quiz questions that deal with the content from that day. You might find that it helps you be a little bit less stressed than cramming everything in frantically before midnight, okay? When you're ready to submit the quiz, you click the submit the quiz, the assignment button. Okay, I've asked that you save your documents in PDF form. And I do want to explain why I'm so picky about the PDF. So for me, I'm able to grade things directly on my tablet. And so if you submit it as a PDF, it's a file size works so that I'm able to upload it into my tablet to grade it, so you get feedback for things that went well as things that didn't go as well, and I can return the assignment to you electronically with the grades on there. So the PDF thing is, part of it is, yes, I'm trying to be picky, but if you send me photos, then sometimes the files get so large that I can't send them back to you and give you the feedback that you deserve, okay? So that's it for the assignments. Grades will be posted. So I do grade pretty quickly. I know especially during summer school, it's really important to you to have feedback on how you're doing immediately. So for quiz 1, for example, you're going to turn that in Tuesday by midnight. You should expect a grade by Wednesday afternoon, Thursday morning at the latest, okay? So I'll also be posting a key for the quizzes. So when you are done with the quizzes after they're submitted, I'll post a key and you can check your own answers as you go as well, okay? And I think that's it in terms of Canvas. I really tried to pare down like all the different tabs on the side so we don't feel too overwhelmed. But one feature I did want to share with you is, can everyone see this to-do list on the right-hand side? Okay, so that to-do list, for better or for worse, as soon as I put an assignment and a due date, those dates pop up right there. And so if you're like me, I really like having things where I can just kind of like cross things off the list. So once you're done with quiz 1, you can hit the X, it'll disappear, you know that you're done with it, and it'll be a way to kind of keep yourself in on top of the assignments that we're doing, okay? Great question. So someone asked, is there partial credit for work shown? Yes and no. So partial credit in the sense that if you are headed in the right direction and you maybe make a sign mistake or something like that, that's not too many points off, okay? But if you're like totally like the wrong method, you made the wrong choice, it makes it a little bit harder because the way I write the questions, there are certain things that I'm looking for. So if you make the wrong choice, I'm not always able to see the things that I'm looking for. Okay, so yes, there is partial credit, and I definitely want to see your work. Okay, this goes for quizzes, but really also for exams. I want you to think about the exams as a way of you communicating your thoughts to me. So if you're skipping a whole bunch of steps, it makes it really hard for me to follow that train of thought, okay? As far as extra credit goes, there are going to be extra credit problems on the exam. And so the typical structure will be something like, you know, there's going to be maybe, let's say 12 questions. I ask you to do 11. You can do the 12th one for extra credit. Okay. All right. Any other questions about Zoom or Canvas?
I do have a question.
Sure.
So I don't see any mentions for homework.
I will send your extra homework to you directly. I'm just kidding. So instead of having homework, so in the past, if you've taken a class with me, we've done things like WebAssign, and it's definitely gotten a lot of mixed reviews. So I thought for summer school, what would be a really useful way for you to spend your time, because I know you're going to have to spend time on this content. The quizzes are essentially like your homework, okay? So your quizzes are meant to be a way for you to practice extra topics that we're doing, but also get some feedback around that within a day or two, and help you prepare for the exam.
So we are not gonna use my math lab?
No.
Great, okay, thanks.
Yeah. So no WebAssign, no My Math Lab. It is all, and I know someone had emailed me a question about textbooks. So if you are in this class, you've probably taken Calc 1. And if you've taken Calc 1, you've probably already bought a textbook, okay? I don't need you to buy another textbook. So I will be doing my notes from the Swakowski textbook. If you look hard enough, you can find some free PDFs online. You don't need to purchase one. But there's also OpenStax, which is a free online textbook as well. So there are so many resources out there. I didn't think it was necessary for people to purchase a textbook, okay? Other sources for extra problems, for sure. So let me, Paul's online notes has a really, really good selection of practice problems. And what I really like about the work he does is when he puts the problem up there, he'll say like, show me the next step. And so if you want to just get the next step shown, he'll show you the next step. Or if you want to show the whole solution, he'll show you the whole solution. Okay, it's not a video-based one. It's definitely you need to read it. It's kind of like a math textbook, but I think he does a really good job of explaining the why behind why we do what we do. And he has a whole lot of practice problems. I think there are a bunch of different YouTube channels out there that I think are really informative if you're more of a video-based person. Yep, some of the other professors have really, really good websites and stuff like that as well. think it's Patrick JMT. I tend to like his YouTube videos as well. I think he does a great job explaining things in sort of chunk pieces so that it's a little bit easier to understand. Okay. Any other questions, folks?
Yes. For the, well, I got a little bit late, but I don't know if you already talked about returning the graded assignments, like the quizzes and the tests. Are we gonna get like some feedback?
Yes, yes. I think that's so important. So you won't, like when you turn in an assignment, it's not a black hole. You will get a graded assignment back.
Oh, okay. And if we have any questions, do we save them for the end of Zoom session?
Yeah, if you have questions on the quizzes, I'm happy to help you out. You can always shoot me an email, for better or for worse. I'm on email quite a bit. And if you have questions, you can like outside of class, you can certainly say, hey, like hang around at the end of lecture. That's totally fine.
Oh, okay. Thank you.
All right. So bonus questions. Again, so sometimes there might be random extra credit opportunities. I don't necessarily know how many points in addition yet, but overall, the extra credit is never really more than like 5% of your overall grade. So however many points we have, it won't be more than 5% of that. All right. So let's go ahead and get started. And I'm gonna go ahead and reshare my screen. Hopefully this works. But we're gonna start with the 9.1 blank notes, all right? So if you wanna pull that up on your tablet or print that out or just have that on a separate screen, that is probably a good idea. All righty. All right, can everyone see the 9.1 integration by parts notes?
Yes.
Yep, all right, cool, thank you. I know sometimes with the screen sharing, things go awry and you think you're sharing something and you're.
Professor, can I ask a
All right, folks. I would hope you have had a chance to get up and stretch your legs a little bit, but we're gonna move on with the lecture right now. So I'm gonna go ahead and reshare my screen. Okay, and again, we're picking up with example number 5 that is in the 9.1 notes. All right, there we go. Okay, so you should be able to see the screen right now. I'm going to start writing, but if for some reason you don't see the screen, please let me know. All right, so example number 5. All right, so we've got the integral of natural log of x dx. And when we look at this, this is definitely an integral that you can find in a table. So there are tables of integration where you can look up the different rules, okay? But I wanted to show us where that formula came from because we can actually solve this using integration by parts. Now, I know I said earlier that with integration by parts that we typically have two functions and that they are multiplied together or they are divided by each other. And when we look at this one, it's so easy to look and say, there's only one function. It's only natural log of x, so how can I even use integration by parts, okay? So let's go back to our color coding, all right? So for all the u's, I've color coded them blue, and it'll be that way in the answer keys as well. And then all of my DVs are green. They're gonna be like that in the quiz answer keys also, okay? And so if I go ahead and I say, all right, well, I see this natural log, and I know using lipet or liate that natural log has to be my u, then I can at least write down that u equals natural log of x. And like someone said earlier, that derivative is 1 over x dx, okay? Now, what does that leave for our dv? Well, the only thing left in there is the dx. And so sometimes when we use integration by parts, it's okay for it to be so simple, okay? That our dv is just dx. Now that means when I integrate, that v is going to be x. So I'm going to go ahead and plug these in. So the integral of natural log dx of x dx is going to be u times v, or we can say x natural log x minus the integral of v times du. Now the x natural log x, I can just keep that way. But one of the things that you're going to find is going to be a real benefit to you in Calc 2 is looking to use algebra, not illegally, but appropriately, to simplify. So for example, I see x times 1 over x. Those reduce to 1. So really, this integral is really minus the integral of 1 dx. And that looks way less scary. So I have x natural log x minus the integral of 1 is x. And then I'm done integrating, so I need my plus c. Okay? So if you've ever looked in the back of your textbook or been like, how did they find out the integral of natural log of x? Well, where it comes from is people used integration by parts to help us get that formula. Okay? All right. So we're going to take a look at example number 6 now, okay? Now, if you're taking your notes on a separate piece of paper, this problem is a long problem, so we want to make sure we leave enough room for that, okay? So let's go ahead and take a look at this. If we're going to set up our integration by parts, I know that as soon as I see that polynomial that has a higher ranking than the exponential, that means that x squared is going to be my u. And it means that e to the 3x dx is going to be my dv. So I've got u equals x squared. That makes du 2x dx. dv is e to the 3x dx. And we've seen this one before, or something similar to this. We need to use u substitution to find that integral. So we're going to get 1/3 e to the 3x. And I'll make a little note here. I think this color that I happen to choose for u sub is orange. All right. So u sub to get that integral of 1/3 x to the 3x. All right, so I've got my setup here. Now I'm going to go ahead and fill in my formula. So I'm going to start off with u times v, or x squared times 1/3 e to the 3x, minus the integral of v times du. And let's clean that up a little bit. So I'm going to take this first term and I'm going to make it 1/3 x squared e to the 3x because I like to have my constants in the front. And then minus the constants that I can pull out here are the 1/3 and the 2. So I'm going to bring 2/3 out to the front. That's going to leave me with x e to the 3x on the inside, okay? Because I have this x and then I have e to the 3x. Now this integral, in order to answer it, I need to use parts, integration by parts. Okay, so this is not unlike the one where we had the e to the x and the cosine x and we had to do it one more time, okay? So we're gonna set up the integration by parts for this second part and see what happens. So u is gonna be my polynomial, or x. dv is gonna be e to the 3x dx. So u is x, du is dx. dv equals e to the 3x dx. And we just saw this in the first part. When we integrate this, we need to use u substitution, and we're going to get 1/3 e to the 3x. Now I'm going to go ahead and write out the whole problem and let's see where we are. So my original problem was x squared e to the 3x dx equals, we had our 1/3 x squared e to the 3x minus 2/3, and I'm going to open up a bracket here. Move this down a little bit. Okay. So we're going to use our integration by parts formula. So u times v is going to give me 1/3 x e to the 3x minus the integral of 1/3 e to the 3x dx. This is going to give me 1/3 x squared e to the 3x minus 2/3. Okay, I'm not going to distribute yet. You're more than welcome to distribute at this point, but sometimes I like to do the whole integral before I distribute. Okay, so when I integrate this part, I have 1/3 as a constant that I can pull out, and I have e to the 3x dx that's left. Okay. So knowing the integral of e to the 3x is actually really valuable because we saw it 1, 2, 3 different times in the same problem, okay? So this is a really good example of why I want us to be able to recognize the u sub, because I don't want us to sit and do u sub 3 different times. Sometimes we move through the problems a little bit faster if we can recognize those shortcuts, okay? All right, so I've got 1/3 x squared e to the 3x. I think let's take that integral before we distribute. 1/3 x e to the 3x minus, all right, this integral is 1/3 e to the 3x, but I already have a 1/3 here, so it's going to be 1/3 times 1/3, or 1/9 e to the 3x. And then I'm all done with my integration, so I'll put a plus c there. All right, looks like I'm all done with the integrals, okay? So last time we saw a case where we had to do integration by parts more than one time. It was like never ending, okay? And we had to look for those like terms that we could combine. But in a case like this, okay, and what I mean by this is that my u is a polynomial, Okay, if my u is a polynomial, then it's going to end at some point. All right, it's going to end at some point. And so when we look at this final line here, there's no more integrals. We didn't have to combine any like terms in terms of the other integral on the other side. So we're good. So at this stage, we're just going to distribute that -2/3 to this term as well as that term. Okay. Let's zoom back in so we can see the whole problem on one page. All right. Silly question, but what was the power of the polynomial in this question?
In 2?
Is it?
Yeah, that power is 2. Okay. How many times did we need to do integration by parts?
2.
2. Okay. So our power was 2. Our u was the polynomial. That meant we needed to do integration by parts 2 times. Okay. Let's take a look at example 7. How many times would I have to use integration by parts?
4 times.
4 times. Yeah, I 100% don't want to do that. Okay, so I'm going to show you guys a shortcut. So this is only if your u is the polynomial. Okay, so only for u equals the polynomial. When the u is the polynomial, we can use something called tabular integration, okay? And so what we're gonna do is we're gonna set up 2 different columns. One of our columns is gonna be for our u. The other column is gonna be for our dv. So our u column is gonna start with our x to the 4, okay? And all we're gonna do to go down that column is we're gonna keep taking the derivative until we get to 0. So 4x cubed, 12x squared, 24x, 24, don't stop there. Gotta get all the way to 0. 0, okay? Now I know I made this table with exactly the right number of boxes, but when you're making your own table, make sure that you go all the way to 0 for your derivative, okay? So all of these, we're taking derivative. In the other column, we're gonna set up our dv, and then we're not gonna take derivatives, but we're gonna integrate. So our dv in this case is e to the x over 2, okay? When I take this integral, I am 100% going to need to use u sum. So the integral of e to the x over 2 is 2e to the x over 2, okay? What's my next integral?
Is it 4e to the x over 2?
Yes, it is, yep. And that'll make the next one 8e to the x over 2, 16e to the x over 2, and 32e to the x over 2, okay? So when we go this way, we are integrating. All right. Now, the reason why we need to make sure we get all the way to 0 for our u is because that tells us when to stop finding integrals, right? So we stop with the dv's the same line where we have the 0 for the u. So like this was my 0, so I stopped, okay? So now what we're gonna do is we're gonna connect the u's and the dv's, not straight across, but diagonally, okay? So we're gonna go like this. We're gonna multiply those. We're gonna go like this. We're gonna multiply, 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 multiply. So we should have 1, 2, 3, 4, 5 terms in our answer, okay? The last trick to this is you're going to alternate sign. So for the first one, x squared times 2e to the x over 2, we're going to keep the sign. So if it's positive, we keep it positive. If it's negative, we keep it negative. But the second set, 4x cubed times 4e to the x over 2, we're going to change the sign. So if it's positive, we're going to make it negative. And if it's negative, we're going to make it positive. And we're going to keep alternating. Keep, change, until we get to the end. And then we're going to write it all out as one long answer. Okay. All right, definitely should have left more space for myself at the bottom. Okay, so my first term is going to be 2x to the 4th e to the x over 2. I keep that sign, so it's going to stay positive. The next term is going to have a coefficient of 16, x cubed e to the x over 2. And that's positive here, but I need to change the sign, so negative. It's less dramatic when there's a delay here. The third term is going to be, let's see, 12 times 8 is going to be 48, and I'm going to keep that as positive. So 48 x squared e to the x over 2. And then the fourth pair is the 24x times the 16e to the x over 2, but that's going to be negative because I'm going to change the sign. 24 times 16 is 384 x e to the x over 2. And I've got one last term, which is the 24 times 32 e to the x, and that's going to stay positive, so plus 24 times 32 is 840 e to the x over 2, and don't forget your plus c. And so there is your answer for a situation when your u is a polynomial, okay? So if I had, yeah, go ahead.
Would it have worked also for the previous problem that we just did, even though it's just 2 times?
Yeah, we absolutely could have used this method for example number 6.
Oh, thank you.
Okay, but let's actually scroll back up for a moment. I love that question because, where did it go? This question, okay? I've had students say, oh, I love this tabular thing, right? Because you just take your derivatives, take your integrals, and then just multiply. So easy. But I cannot use that method for example number 2 because my u is not the polynomial. Does that make sense?
Yes.
So we want to make sure that we're making decisions for ourselves that are informed decisions, and we're not just randomly like, all right, let me just try this method, okay? All right, let's see. 96 for the third term. 12 times 8 is definitely 96. Thank you, folks. You know, the worst part about all of this is I feel like I did all these problems in advance and I can't multiply. All right, so we've got 12 times.
Also, the last term, I
Yeah.
didn't get 840.
All right, is the 384 good? 24 times 16 is 384. 24 times 32 should give me 768. Is that what folks got? Yeah, okay.
Yeah.
Thank you. Yay. Okay. Cool. So a handy method to use, but definitely know when you can use it and when you can't, okay? All right, so we've got 2 examples left here. Looks like we're doing super good on time. So I'm quite pleased with that. All right, so example number 8, all right? So we have here a situation where we have x to the 5th times the square root of x to the 3rd plus 1, okay? And sometimes with the roots, I like to write them as terms with fractional exponents, because again, anytime we want to use the power rule in calculus, we need to be able to see what number the power is in order to use it. So what I mean by that is we've got the integral of x to the 5th. That part is fine, but it helps my brain if I write this as x to the 3rd plus 1 to the 1/2. Okay. Now, when we look at this, okay, sometimes we have to be clever about how we choose our u's and our v's. So in this case, if we set it up like this, okay, so let's say we're like, I'm going to choose u as x to the 5th. That makes my du 5x to the 4th dx. And then you get to your dv and you're like, stuck on what that integral is. Now we're going to learn how to handle integrals like that, but at this point, we don't know how to find that integral, okay? But what would make my life easier is if I could have, like, if there was like an x squared somewhere in that dv, then I could use u sub and it would actually make my life easier, okay? So what I'm going to do is I'm going to erase this setup, and I'm not going to erase it, I'm just going to shrink it. And we're going to rewrite our integral even more differently, okay? Now this next strategy is going to be one that we use for a lot of the upcoming days, all right? This idea that we can take something like x to the 5th and we can split it to be like x to the 1st times x to the 4th. Or we could write x to the 5th as x to the 2nd times x to the 3rd. Okay, so we have some choices here. So in this particular case, because I said life would be easy if I had an x squared, I'm actually going to write my x to the 5th as x to the 3rd times x squared. Okay, so that x to the 3rd times x squared is my x to the 5th. And then I have to write the rest of the integral as well. And now what I'm able to do is say this is my u. And look what I did. I was able to make my life easier. I've got that x squared in there, which makes my dv something that I can take the integral of, okay? So if we do a new u sub setup here, I've got u equals x cubed, du equals 3x squared dx. dv is x squared x cubed plus 1 to the 1/2 dx. And now I can use u sub to find my v. Okay, we're going to do this question down here. I think this one is a little trickier to kind of imagine in your head. But the good u to pick here would be x cubed plus 1. That would make du equal to 3x squared dx. And because I only see an x squared, I'm going to divide both sides by 3. And when I plug these all into my u sub situation, I end up with 1/3 the integral of u to the 1/2 du. And that is going to give me 1/3. Okay, so we're going to take the 1/2 power and we're going to add 1. That gives me 3/2. And then I'm going to go ahead and take the reciprocal of that for my coefficient. Okay, so that is my integral. But the way I've written it, it only has u's, so I want to make sure to put my x's back in. So we could say where'd it go? All right, we could say that this equals 2/9 x cubed plus 1 to the 3/2. That is our v. Okay. So that's definitely more of a setup, but in this case, we're only going to need to use integration by parts one time, okay? So let's come back over here and let's set up our integration by parts. So first thing I need is my u times my v. So I've got 2/9 x to the 3rd times x cubed plus 1 to the 3/2. That's my u times v. Minus the integral of v du. So I'm going to take my v times my du. Okay. And then we'll take this, keep it like that. And I'm going to go ahead and pull out some coefficients here. So I've got a 2/9 times 3. That's going to give me 6/9, and that reduces to 2/3. And look what I have left in here. X squared, x cubed plus 1 to the 3/2 dx. So even though this first part was so much work with my u sub in the orange, I can actually use a lot of that again when I do u sub here, okay? So in order to evaluate this, I'm going to need to do u sub a second time. So u is going to be x cubed plus 1, du is 3x squared dx, and du over 3 equals x squared dx. And when I do that, I'm going to end up with 1/3 the integral of u to the 3/2 du. And just like before, I see a fractional power, so I'm able to use the power rule. So power rule says I take the power, 3/2, and I add 1, 5/2. And then to find the coefficient, I take the reciprocal. Okay.
Professor, sorry. For the first dv, where did you get the x squared from?
Like this one?
On the other side?
This one.
Yes.
That was, it's not there. It's more like, wow, my life would be easier if it were there.
Okay.
Okay, so it kind of provides the rationale for why we split the x to the fifth into x to the third and x squared.
So it's just like thinking algebraically.
Yeah, yeah. All right. So let's see, where were we? Okay, so we've got our 2/9 x to the third, x cubed plus 1 to the 3/2 minus 2/3. I'm going to set up a bracket because I have a lot of stuff to put in there. This is going to give me 2/15. I multiply straight across. My u is x cubed plus 1, and I'm going to raise that to the 5/2 power because it's u to the 5/2. And now that I'm all done with my integration, I can put a plus c at the end. Now, someone asked a really great question earlier about simplification. And I think that in Calc 1, there's a little bit more emphasis on putting like 3/2 into a radical form or 5/2 into a radical form. But I think what you'll find with Calc 2, and especially this first unit, is we're doing so much work already that at the end, we usually just leave our powers as either positive exponents or fractional exponents are fine, okay? So on an exam or a quiz, you could totally leave it like this for the first part, and then maybe just like combine those coefficients. You get 4/45. Okay. You really don't need to go any further than that. That's fine. All right. So we've got one last problem to take a look at, okay? If you think back to our beginning, we talked about lyate or lipet. And so we've seen cases where we had the log. That has to be our u. If you see a log and you're doing integration by parts, logs have to be the u. And then we kind of skipped over that I. We didn't really look at any examples that had the inverse trig. And so this is going to be our last example, all right? So this is our last example with the inverse trig because over the next 2 days, we're going to see a lot more trig stuff. So I just want to kind of, you know, reintroduce those ideas into our brain. All right. And here we go with our last question, okay? So this kind of goes back to the idea of integrals, that integrals really represent area. Like, no matter how complicated the things get, what we're finding is either a numerical area or we're finding a formula that will help us find the area. And so in this case, we've got our inverse tangent graph, and we'd like to find the area that is that blue area. So between 0 and 1, between that curve and the x-axis. So from here, we could set up an integral. We can say that this is the area is going to be the integral from 0 to 1, okay, because I start here and I finish here, of the function okay. So the way this is set up right now, this is very similar to our log one, where it looks like it's just one function. So how are we going to use integration by part? But remember, we can kind of keep it really simple, where that dv is actually just our dx. So this is going to be our u, and this is going to be our dv. So u equals the inverse tangent of x. You might also hear it as arctan, okay? And that is a good derivative to know. It's going to be 1/1 plus x squared dx. Our dv is much simpler. dv is dx, so v equals x. And now we're going to plug those in to our integration by parts formula. So u times v is x arctan of x minus the integral of v times d. Now I'm going to drop my bounds until I get to the end, and then I'm going to put the bounds back in, okay? This, I think, is a really good case to say that sometimes we need more than one technique to solve a problem. So what I mean by that is, I'm going to go back to our original question that we started off with, which is, can you see a function and part of its derivative in your integrand? And we're going to use u substitution here. U is going to be 1 plus x squared. Du is going to be 2x dx. But I don't see 2x, I just see 1x. So du over 2 equals x dx. And I'm going to use my u substitution right here. So I have 1/2 the integral of 1 over u du. Okay. The integral of 1 over u, what is that?
ln x.
It is natural log x. Good. So I have natural log of, and I'm going to put back in my x's. So 1 plus x squared. Now I'm not going to have a plus c because what I want to do is plug in 1 and 0 into that. Okay. So I've got 1 arctan of 1 minus 1/2 natural log of 1 plus 1 squared is 2 minus 0 times arctan of 0 minus 1/2 natural log of 1 plus 0 squared is 1. So 0 times this is going to give me 0. Natural log of 1 is also 0. Okay, so natural log of 1 equals 0 is actually a really good thing to help us simplify a lot of things. So our whole second term goes to 0. Now, what we have here is we need to find arctan of 1 minus 1/2 natural log 2. Now, arctan of 1 is really saying what angle has a y over x value of 1. Okay, so if you think about your unit circle, the angle that has a y over x value of 1 is pi over 4. So that means I can write my final answer as pi over 4 minus natural log of 2 over 2. And again, I don't need a plus c because I plugged in bounds. Okay. So that is how you can do a problem using inverse trig. Those don't come up quite as often, which is why I saved it to the end, but don't you worry, we're going to spend a whole lot of time, especially over the next few days, working with trig and inverse trig. So this is just the beginning. I would definitely go back and look at your unit circle if you have any questions about that, okay? So I'm going to stop sharing my screen right now, but after we finish class, I'm going to go ahead and post my notes to Canvas. So you'll be able to go back and look at those in case there's anything that you missed, all right? And before we finish class here, if you have any questions, feel free to stick around. I know it's the first day, so there's, always questions. But I would definitely recommend starting your quiz number 1. I think the first 7 or 8 problems are all using integration by parts. So it'll be a good chance to kind of practice what we've gone over today. Okay? All right. If you don't have any questions,
Thank you.
feel free to take off. And I will see you folks later.
Thank you, Professor.